Beautiful students, today we're going to be tackling a question on Hooke's law, and this question will test our fundamental principles of how well we understand Hooke's law. So they said a spring has a spring constant of 6 Newton per centimeter, which is highlighted here, 6 Newton per centimeter, and 6 Newton per centimeter. It is joined to another spring whose constant is 4 Newton per centimeter. A load of 80 Newton is suspended on the composite spring. What is the extension of the composite spring? So basically, these are two springs that are joined together. And one thing I like to say is this. When I have a rope, right, when I have these two springs, the same 80 Newtons is acting on this guy as is acting on this guy. Because let's think about it. There's a flow. This is spring 1, spring 2. This is the weight here. The 80 Newtons, right? The 80 Newtons is pulling down, causing this guy to extend. This guy is also pulling down, causing the other guy to extend. So that same weight is acting upon it. It's acting upon the two springs. That is one concept I like to mention, that the same force acts upon the two springs. And because of the nature of this question, we're actually just going to derive the formula for composite springs attached in, I like to say, series. So now these two springs will each have their own extension. And now we remember Hooke's law. Remember Hooke's law to be that F is equals to KE, right? And now using F equals to KE, we know the same amount of forces acting upon them. They have different K's and they'll have different E's. So let's find the total extension, since that's usually what questions ask for. So we say extension is what? F over K, right? And so this spring here will have its own extension. I'll call it E1, and that is F over K1, since this K has its own extension. And then E2, there will be another E2, and that will be F. I'm using the same F because it's the same force acting upon them, over K2. And then now there's a total extension. I'll call that ET, and that is obviously going to be E1 plus E2, and in our case that's F over K1 plus F over K2 is equals to total ET. So total ET will be F over KT. KT will be this composite spring. So basically, when we talk of composite spring, it's saying that these two springs can be replaced with just one spring that will have the same effect, the same extension as this guy. And so that would be KT, which is the spring constant of a composite spring. Now, F over KT, you factor out the F, K1 plus. And now you can divide both sides by F. So now you can say 1 over KT is 1 over K1 plus 1 over K2. Beautiful. Now for this question, we can find the composite spring. We'll use our calculator for this question. So the composite spring's constant in our case, or the composite extension, will be F over KT. And now the composite spring constant is this. So it will be, obviously, it's KT is equals to 1 over K1 plus 1 over K2, the inverse of this guy. Now using your calculator, you can quickly run that calculation now. So that would be KT is 1 over, from the questions, 6 and 4. And I'm going to quickly calculate that. And that is 2.4, basically 12 over 5. So KT is 2.4 Newton centimeter. So now our total extension will be 80 all over this 2.4. And that is the 33 centimeters. It's 33.33, but keeping everything to two significant figures, as you can see in the question, is 33 centimeters. Now, Alternatively, you can actually just find the extension for each, which is going to be 80 over 6, and then do for 80 over 4, and you also get the same answer, which we can test. We can actually just test it now, saying 80 over 6, which is 80 divided by 6, which is 13.33, and then 80 over 4, which is 20. And you see, if you add these two, you get the same answer. That is the quicker method, but I wanted to explain the principle of composite springs using a question. Thank you very, very much. So the shortcut is just to know for springs in constant, springs in series, the composite spring constant will just be 1 over kt would be 1 over k1 plus 1 over k2, and it's an infinite series. It just goes on like that. Thank you.